But they sell it at Home Depot calling it travertine marble. But it's never been metamorphosed. Right. And so travertine is freshwater limestone. And what is limestone comprised of, or composed of? Calcium carbonate, or calcite. So as the groundwater drains and leaches through the soils of that calcareous loess, it becomes super saturated with calcite because in the soil zone, that calcite dissolves, okay? And so there's a high CO2 level, all right? So it's flowing underwater, comes back out at the stream, underground, flows back out at the stream, super saturated with calcite. Now, it's also got a lot of CO2 in it. It's basically like carbonated, okay? Just like a carbonated beverage. And remember, more CO2 dissolves calcite, less CO2 results in precipitation of calcite. But the conditions to precipitate calcite to the surface has to be perfect, okay? And so what happens is, as the water comes back out and is exposed to the atmosphere, that CO2 level tries to equilibrate with the CO2 level in the atmosphere, okay? The CO2 level in the water. So their outgassing occurs. But when that happens on a regular stream, it's usually only at the surface, okay, where the water is exposed to the atmosphere. So not that much CO2 can outgas that fast, okay? But here at the waterfall, what happens is, as it goes over the waterfall, you have this carbonated water, and you have little splashes and droplets and streams of water, so there's a lot of surface water, surface exposure to the atmosphere. So you have very rapid degassing. So the CO2 is lost really quick, and you have sudden precipitation of calcite. So we have the siltstone up there, but if you look, you see all this kind of, you can see the limestone down here, and that's called waterfall tufa.
Waterfall what?
Tufa. T-U-F-A,
waterfall
or travertine. Travertine is a general term for freshwater limestone, and it can also form in hot springs, and tufa forms at waterfalls.
So it's really rich in...
Tufa forms at waterfalls.
It's limestone, calcium carbonate. And so there's tufa actively forming where the water is flowing over at the punch pool locations here. And you see where there was once an active waterfall that there was tufa that was forming there. So limestone...
That was a previous flowing waterfall.
This helps to armor this waterfall even more. Now, there was a lot of work done on waterfall tufa back in the 50s and 60s, and it was always supposed that because if you look around, waterfalls, it's really misty and moist area, so it's a site where there's a lot of moss and lichens around here, right? Liverworts, I don't know which one's which. But what do those guys do? How do they respire?
They do, but it's osmosis. Oh, and I was thinking like osmosis.
So what's the product of photosynthesis?
Oxygen.
Right. So they uptake CO2, they output oxygen. So when the photosynthesis removes CO2 from the water, and there's a biologic mechanism to have calcite precipitate. The rule is that if you reduce CO2, you can precipitate calcite. You increase CO2, you dissolve calcite. So for a long time, it was thought it was a biological phenomenon, and that it was a biological phenomenon. When it's actually been shown in recent studies in labs and in the field, that it's the physical process, the geomorphology, that's really that forms the large deposits of waterfall tufa, and that a second type of tufa forms, it's called spray tufa. And you can see that.
Spray tufa.
Those are all liverworts and lichens all along that face right there. And you see how it's all like that druzy texture? That is all that's spray tufa. Okay, so that's because of the biologic removal of the CO2, whereas that's being because of the physical processes at the waterfall. More water surface area is being exposed to the atmosphere. So if this is being actively formed at the waterfall site, it takes the physics of the waterfall to form this tufa, okay? What can we do if we have a waterfall retreat path? What might that be able to tell us about? How might we be able to predict the rate of mixed point migration?
We have what?
We have this boulder path where the waterfall retreat is.
By the amount of
Well, it's carbonate, right?
Yeah,
it's got carbon. So it's being precipitated actively right there. So by using carbon dating on the Tupelo trail,
carbon dating on the trail,
we would be able to,
especially on the walls,
probably get an estimate of the waterfall retreat rate.
You can estimate the waterfall retreat rate.
Floats or the boulders. Right, they can be transported.
Boulders can be transported.
It'd be hard to transport these, but it can happen.
It's not a reliable way to measure the rate of nick point.
Not straight down or
Yeah.
What is all the little reddish spots then?
Those are oxygen. You'll see there's some red spots, and those are, you can see them in there really well.
Red
those
spots?
are ketogenic structures. Those are
Ketogenic structures?
oxidized root caps.
Oxidized root caps.
Miocene age.
From Miocene age.
Root caps. So there was a root there.